So today we're going to complete the last of Mr. Trucking and Farming's from Leicestershire stuff, and it's a President Grant. We don't normally do SSB stuff, even when it's one of the very few legal UK sets, which this is. Said before, not interested, but we'll do it to help this gentleman. The other one went back today, the non-repair, where it had no transmit. So I've kept our mic out so we don't have to undo his new mic. So 31st of October 2025, President Grant 2 Mark II, whatever. Trucking and farming. Right. I wonder which end you open. And my usual duster is in the wash. Right, so we're not going to need to take any accessories out because we've got a power lead and we've got a mic. He actually got an instruction book. I never seem to get instruction books. I don't think my wholesalers love me. I will give an instruction book to him. And because a lot of sets, it's online instructions only. Don't expect this is going to work like that Harvard 404 did yesterday with 0.21 microvolt sensitivity. So we're going to need to take the speaker lids off, but I'll tell you what, we'll do the parameters first. I've only got half an hour as ever. But you see, this is what you can do when you don't have a television. When you've got time between the normal jobs, you get on with something like this instead of sitting down and watching the telly. See how it works. And it is 80 channel optimization, new set. Oh no, we're not taking the things off yet. Right. I'm still geared up for a uniden lead, so because I was doing that. Oh no, I was testing. You know what? I got the two chassis. I got our President Grant out. I got the customer's one, which we couldn't do the transmit on, and I didn't know which was which. I actually had to power both up to see which one didn't work. He nearly ended up back with the working one, my brand new one. Oh dear. Then I put one of my lids on and one of his lids on, and then I looked here and his are all scuffed round here. I thought, hang on, that's my speaker lid. Anyway, we got there. I put mine together, I just have kept the mic out. So with my mic, we will plug in. So if it's anything like my brand new one, which we optimised couple of months back now, it was about 3 watts, wasn't it? So there we are, 13.8 volts. Let's power it up. If I can find the on and off switch, there we go. It comes on the 19. It's on UK channels, EU channels. Hopefully when I press band, AM, FM, it's not set for UK, is it? How annoying. Let's have a look if this is how you set it. Yeah, it is. I think that's done it. And there goes the phone. Oh, another one of those fake calls. This is the bank security service. There is a pending transaction for 300 and something pounds from Amazon for a... Oh. Yeah. Real banks don't go into those kind of details. And anyway, I've only got about £3 in the bank. So if there's a £600 transaction, it'll bounce, won't it? For a load of silliness. I had an old lady phone me up. I had to go out 7.5 miles to comfort her because she's scared that this is true, and it isn't true. I says, look, you haven't even got that kind of money. I haven't got that kind of money, so it's not going to happen, is it? No, it's not going to happen. Right, what a waste of time. We'll do our usual thing when we're doing 80 channel sets. That'll be CPT channel 1, that'll be UK channel 1, UK channel 1, and that will be UK 40. It doesn't have low power. I don't think it's even got variable power, has it? Not that I can spot quickly. So it won't have got that. I'm going to tick off meter lamp. It doesn't have a meter, and they don't have public address, which doesn't help fault finding. Not applicable. We're not testing it. I'll write the words new in there, and we can tell the speaker works. They don't have real meters, do they? These things. None of these modern sets do. You can take the transistors out, and it still says it's transmitting. Right. So we'll. Just for our own thing, we're not going to write this one down. Let's put picture in picture on. Let's go to camera 1. The mice haven't moved these back, have they? If they can upset the cameras during the night, you'd think the mice would come in the next night and put it right, but no. I remember living in a town as a boy, in the 60s and 70s, and we didn't have mice. Right, what we want to do is plug into the test set. Because we always do the current consumption on channel 20, I will do the current consumption on channel 20. And at the moment, we're doing 2.213 amps. This is FM, that's how we do the test. 2.213 amps, which for whatever output we're about to show you, it's 3 watts. And if we go to the 30 watt scale, you see it's just under 3 watts. So I'm being generous by saying it's 3 watts. I think ours was less than that. Oh, we're not doing that though. We're going to write down channel 1. So here we go. Channel 1 is 3 watts. Channel 40 UK is 3 watts. And channel 1, let's go over to CPT. Channel 1. And it's 3 watts, so it's very good across the wide bandness these radios are. Is that a phrase of putting it? But you know what I'm getting at. Across those 80 channels, it's absolutely perfect. So, deviation on this test set. Oh, I have to go back to channel 20 because it's a tuned thing. So just go back to UK. 20. No, that's not UK. 27. That is. Back to channel 20, so we don't have to retune these deviation meter. Wallow. It's showing us 0.6. which it might be. We won't be doing the VCO, I don't think. And let's have a look at the frequency. The test gear's been on an adequate amount of time. 2779093, 2779093. So the RF meter, it's probably fake anyway, is showing, I'm going to put it's showing 9, whatever that means, and let's put in the signal generator at exactly the same as the transmit to be absolutely fair at 2779093. So 27790. I'd like to get at least one adjustment made on this before having to go for lunch. Well, I want to go for lunch, but you know, it's got to be exact times. Right, so we're exactly on the same frequency the thing's transmitting on. It's absolutely fair. We need to plug our test equipment into the extension speaker socket. Short out our crocodile clips like you'd expect. And if it's got RF gain, not on the front it hasn't, so that's good. Oh, first of all, while we're on S9, it's showing S9. Let's just fiddle with the signal generator. It's actually showing S9 for 56. Now, 56 is a correct figure if it's a ham radio on HF. But this isn't a ham radio, it's a CB radio, in which case it's 100 microvolts. So it's kind of right, but it's not right for a CB. So, there we go. I think they obviously want ham radios to look more generous. The kind of ham radios I've got don't have S meters. Right. Usually turned out of ex-business radios. So, we've done that. Sensitivity. Go over to the synad meter. Turn the volume up so we've got a good AGC. Turn the squelch down so we can actually hear it. It's got auto squelch. I tell you what, it's very good. We'll start with 20 because that's where I am at the moment, and it's 0.43 microvolts. Let's go down. It's 0.2. See whether 10 is any better than 0.2. It's still 0.2, so yeah, very, very good. Right, turn the squelch to full. And put extra box in for ASQ. It's got auto squelch. Full squelch is what? It is 3 millivolts, bit tight. There's no hard and fast rule on that though. We'll turn the squelch down. Turn the signal generator to 0.3 of a microvolt and put it to standby. Set the squelch there, signal generator back on. Not quite in at 0.3. 0.45. Yesterday's Harvard base station was better than that. And it was actually exactly the same on receive. 0.45. Let's see where auto squelch is. I like auto squelch to be about 1.6. It's 1.7. you can't argue with that. That's excellent. So there we go, we're done. Open it up, see whether we can get a bit more power out of it, but of course it involves an entire retune to do that. It's not just twiddle something, things have to be zeroed and nulled and all that, so it's quite a pain in the what's-it. We have a different fee for these. There we go. Right. Looking for a sharp thing. That's really nicely done. They've taken the wire over. It's not just been buttered up and soldered. The wire has been put in the SO239 first and then bent down to the board. And that's correct procedure. This needs to be absolutely smooth, not a snipped off thing like we had in a President set the other day. And when I actually did the figures, I mean, I could have looked on the spectrum analyzer, but we were actually getting more power once I'd snipped off the barb. So that was a poor show. But whoever designed the way this is to be put together, that's absolutely 100%. So I'm not a President lover, but that is credit where credit's due. Really well done. So we need our service manual. This isn't the right service manual, but it's a near enough service manual to do this. We wasn't near enough to sort out the no transmit one, but it's near enough for this. So, in fact, the adjustments aren't, because it's a wide band set, as we've seen from power here, it makes no difference what channel we actually do it on. So we're going to follow the instructions exactly. When it comes to the, if there are some separate ones in receive, and I can't remember, it's 2 months since I did one, we may go to channel 40 for EU rather than channel 20. So they want you to be on what? They want us to be on test point 302. They want us to be in receive mode. They want us to be on AM or FM. And they want us to be on channel 20. So let's be clear. AM, FM, EU, receive mode, channel 20 is point 1. We're adjusting L304. There's a photograph, if I remember rightly, of what they want you to help you to find. So L304 is there, and test point 302 is what we're looking for. So I will need to go and get our little oscilloscope, and we'll use it as a frequency counter. So we are kind of doing VCO. Let's pause the video. Right, I've soldered in a pin because I want this to read properly. It doesn't matter when it's my set, but it does matter when it's somebody else's set. So we've soldered in a pin into test point 302. I don't know whether the chassis is ground or what on these. And if I knew, I've forgotten. So test point 302 with the clarifier position in 0, which we are. You can't see that oscilloscope. Right. Adjust 304 to reach 37.9 000 plus or minus 20 Hertz. Well, I'll show you where 304 is. I think it's that one. It is that one. So, as you can see, it's absolutely exact. Let's just see whether we can make it more exact. That's the wrong way. That's also the wrong way. What about that? 37.900000. So we have now done, I'm going to tick these off on this manual. At the end of the day, it's part of the costs. So next, they want us to go over to USB, and they want us to change test points. So I'm going to turn the radio off. We'll solder in our test point somewhere else. And this time, it is test point 303. So 303 is there. So I'll pop a bit of solder on because it's that horrible solder which they have to use these days. And we'll take off my pin. And we'll put my pin there. Switch the radio back on. And connect my probe onto there and switch, as they say, to USB. So be absolutely sure, USB channel 20. UK FM, FM, UK FM. What on earth is happening? Let's start again. Is this a different version? Is this not a Grant 2 Mark II? I think this is an earlier version, isn't it, folks? So we need it to be, so it doesn't smoothly go from one to another. It has to be set for EU. Yep. Well, would you work that out? No, you wouldn't. I wouldn't. Just didn't. So it's not the same as mine. So, here we go. We're definitely in USB, we are. We're definitely on channel 20, we are. With the clarified position in the centre, connect a frequency counter to test point 303 and adjust L306 to get 10.6975. We're miles out. Absolutely miles out. So 306 is the end one. So 10.6975 with 7345. Wrong tool. So let's get, this is step 4 we're on at the moment. Clarify to centre position, connect to frequency counter and dummy load, which we've got on the test instrument. Adjust L305 for 27205. So instead of using the oscilloscope, we'll now go over, I'll just take that off. We'll now go over to the signal generator, the frequency counter, all that kind of malarkey, and we'll do 27205 on transmit. So I'll key it up. Of course we're on the wrong band, aren't we? We want to be on FM. There we go. 27 is off frequency. 20, which we knew it was low, so we'll bring it up. It might be that the others will come right now, or it's just a totally different version. So there we are, 20500. So we are set. So I can tick that one off. Then they want you to go into UK. So I'll just have to reprogram it again. And they want you on channel 20. And they want us to adjust RT302 for 2778125. Well, it's 79125 because they've got that number wrong. That's channel 19. It's channel 20, of course, we're setting it on. So 2779125. It is right. It is now right. But I need to know where RT302 is, just for this demonstration. And it's this one here. So we will give it a little twiddle, even though it's spot on. There we are. That's gone down. That's gone up. This is kind of your UK channels offset. So your CPT channels are done one with the coil. The UK channels are then just trimmed to be spot on. Like an afterthought. So we've done that as well. Now I'm going to go back to stage 3 and we'll go back to putting this on CPT. And we'll see if we can get a different reading now on USB. Otherwise I'll have to twiddle it back to where we started. I didn't touch that one, but I did touch that one. So again with the test probe on. It's absolutely nowhere near. Right, back to this. I'm on a different frequency counter. We're on this frequency counter instead of the one built into my rather expensive oscilloscope. So this is the kind of figure we're looking for. So the instruments don't like each other. This is why we have more than one instrument, and why you're a bit handicapped if you don't have more than one instrument. So we may remember this set is a different version. This is the President Grant 2 ASP. My Grant and the one which we couldn't fix is the Grant 2 Mark II, and this manual is for the premium model. So, you know, things aren't perfect, but most of this should be right, including this. So 10.6975 when the camera decides to stay put. Let's see if we can turn it with this one. Yeah. And we're looking for 6975. LSB which should be 6925. And very slightly high on that one. Oh no, it's slightly low. What am I looking at? 6925. 69 was 23, wasn't it? Oh, except the clarifier wasn't at 0. Does that make any difference? No, it hasn't made any difference to that one. Let's go back to USB. Six nine seven four toggling 69 69. I've got it high, haven't I? I thought I was wanting a lot of twiddling. 6975. There we are, 6975. Go back to LSB. $6925. So those are now both done correctly using that frequency counter instead. So that's the Marconi one. Okay, so going to AM. I'll tell you what, we'll disconnect. I'm not going to take the pin out, but we'll disconnect for now. So put my earth to the nearest can. So with the clarifier, we're on stage 6 now. With the clarifier in center position, which is where we are, connect a voltmeter, this is the VCO, to test point 301 on channel 40. So switch back on. So we want test point 301, let's find it. Test point 301, we've already been on there. And we're looking for 1.4 volts. We're going to be stacking radios in a moment because I want to do the Uniden on the air test. Let's just see what it is for a start. So it should be 1.4 volts, it's 1.54. So we're going to need to adjust that. There you are, you see, VCO's out. These are actually 2013, these sets, so they're now 12 years old. Where shall we put that? On the transmitter, I think. Okay, and we're going to adjust oh, it doesn't tell you what to adjust. It says check it. Well, we're checking it and it's slightly out. Plus or minus 0.2, so therefore anything between 1.2 and 1.6 is okay. And it's within that, so it's lucky it's 1.2. So we've checked that, and then we go to channel 1. Would help if they told you how to adjust it. And they want you to check that it's now 1.2 volts plus or minus 0.2. And it's 1.2 volts, very, very close to. So that one's nearer than the 40, but that is all within what the manufacturer says in the manual. I'm glad about that. With the clarifier in the centre position, go on test point 302 and check that we're on frequency. So I'll go to channel 20. May as well use this frequency counter. Just hold these on for now. Just hold one on. Test point 302. My fingers may affect it. We'll see what we get. We've got to look at the table. So it's for UK, for CPT channel 20, should be 37.9. 39.8975. 9. At the same time, is it on frequency when we're going to transmit? I'm not sure I like some of these methods. So we're going to change to going into transmit. We are going to change into going into transmit. What are we on? Okay, so that's the test point. Let's now go into transmit. It's all right doing these test points and things, but that's not now on frequency. Bit of a compromise, isn't it? I want to go back to this now we've done that. .6975, 10.6925. We've checked it on channels. Yeah, so we're now down. So we check with the frequency list, and it's between one way and the other, it's very, very slightly out. Point is, it's transmitting on frequency, and the test point's very, very slightly out. Don't know why that is, but the SSB test point is spot on. I think the point is, I'm used to UHF business radios, and the very slightest error, and it's all amplified a long way. Right, so that's the first page dealt with. So they want us to go on to USB channel 20. They want us to adjust RT 201 and 202 to fully counterclockwise. I think they're down there. 202 and 201. Yes. 202 and 201 fully counterclockwise. So that's what we'll do. 202. The only trouble is trying to see, because they go round in circles, this type of potentiometer. So that appears to be fully counterclockwise, and with here. And they want us to check for 550 milliamps on the ammeter without speaking. Very slightly low. Do these adjustments again. Just in case it's the opposite way to what I'm expecting to be 0 for fully counterclockwise. Just try that. No, that's wrong. Well, I've got these in the, and we are within the 0.5. I've got 0.45 on the ammeter, and it's plus or minus 10 milliamps, so we are all right. So RT201, which is the first one, you want you to add 10 milliamps to make it into 0.65. And I'll have it just under, because we were just under before. And then they want to do the same with RT202 to 0.75. And I've got 0.7. .49. So that's those set. Then looking at a power meter, and this time now this is where we don't have a tone generator for SSB, nor are we buying one because we're not getting involved with SSB. We're only doing this to help somebody. But I'll use this tone generator, which is totally wrong, but it'll give me a good idea. Because we're adjusting peak. So 2, 1, 7, 8 and 9. I'll show you the meter. Because the peak's going to be the peak, whether I'm using a two-tone oscillator or not. 7. Definitely the peak. So that's the peak done. So we're now on the final one on this page. Go to AM, it says, and adjust L216 for maximum reading on the RF power meter. Then turn it 180 degrees counterclockwise. Well, that's RT203. So L216. So that's that one. So L216, maximum reading on the RF power meter in AM. So just for your information, it's 1.8 watts. So that was already spot on. Then we go to RT203. Let's just find that. RT203. Now this is where they're not quite where they say in the manual because it's a different radio. (207, 4, 3). They want you to turn this . Oh, we've missed something here. We should have turned 207 and 205 clockwise. 207 and 205 clockwise. (207) and 205 clockwise. Then adjust 216 to maximum, which I'm sure it still is. just under 2 watts, and then adjust .203 to center position. More or less is. So in USB mode, we need to adjust the output for 11 watts peak envelope power. Plus or minus half a watt. So we'll do a wah low, I think. It's supposed to be two-tone, but we'll do a wah low and it'll be, I'm sure it'll be near enough. 203. 203. Let's have a look what the meter says. Wah low. Not sure where they get 11 watts from. Are we on the right mode? USB, yes, we're on the right mode. .203. Wallow, wallow. And then connect an RF probe to test point 201. And test point 201 is the aerial connector. So where have I put our great big Russian RF meter? Help if there wasn't a bleep, wouldn't it? To be honest, there is nothing, which is how it should be. I'll just see where 206 is so I know exactly what I'm doing when I get there. 206. 4, 5. .206 is that one. So key up. And that's our null, which was correct anyway. Then they want you to do FM. And they want you to adjust RT204 for 3.8 watts. Well, it's the old Cybernet thing, isn't it, that? Setting the radio to 3.8 watts so it can get through customs. We'll set it to 4. RT204 is what we're looking for to do that. RT204, which is there. Yeah, we've got 4 watts out of it. And Then we're going to AM. And now we're in AM. We are going to set 207 clockwise. So 207, let's find 207 clockwise. Well, he's actually at full clockwise right now. 205 to 95%. So just drop that a fraction. And 207, 207 clockwise. (205 to 95%) and then 207 to 90% modulation. So we'll go into our signal, into our deviation modulation meter. I'll have to tune this in. Wallow. And we're adjusting 207 for 90%. Well, 90% is full scale deflection on our test, and I'll do the Wallow on that, wherever I've put my glasses. Where have I put that? Oh, there they are. Okay, so 207. There we go. That is set. So then we're going to go to FM, and we're going to do RT301. They say for 1.9 kilohertz deviation. Well, we'll see what we can get. And I'll start off by using this Marconi test set, which isn't always accurate on deviation, and then we'll move to the one behind when I've got it to how I think it should be on this test set. So right now, let's look at what we've got for deviation. Wow, it's about 3.5 it says. So we're going to have to go straight over to the other one because that's over the top, and I don't think this test set is reading right today. So plug into the other test set. The deviation is on that test set with the other glasses. Wow, that's absolutely spot on at 2.5 peak. So let's see where that was, because I haven't adjusted it unless it's been part of the initial setup. I haven't knowingly adjusted it. So 301. It's there. We haven't touched it. We're not going to touch it because it's right. That one there, 301. So, I want you to go. Oh, we're not in Russia. The next 3 points are for Russia. It covers RT 208, 209, and 210. So that's transmitter done. So now we are on receive. So what's they trying to get us to do? Signal generators to 27205. I don't think we need this big Russian RF voltmeter. 27205. So reset this. That's 204. .205 it is. And what do they want us to do it on? FM. And we need to probably put an earth on our speaker. So what we're going to be looking at, connect an HF generator and adjust L9 to reach 3 volts. I'm not sure what we're adjusting. Doubt, do we? No, it's getting its earth through the aerial socket. So test point 1. Test point 1. Surely that's the detector and it's done with the oscilloscope. You know, is this some balmy method they've cooked up? Right. So they want test point 1. And they want it to be 3 volts plus or minus 0.1. And they want minus 47 dBm, which is about S9. It's detector this, isn't it? We use the oscilloscope for this. So the way they want it, I mean, that's. Let's show you the oscilloscope at the same time. It's like they're doing this for people who've not got an FM signal generator. It's just, to me, it's balmy. So look, that's our peak. So we would normally leave it there, but we've got 3.46. And they don't want it to be 3.46. The highest they want is 3.1. So we're going to go clockwise. And we're just detuning that. That's as high. That's the highest they want it to be, but it's not quite the peak, but pretty close. Not sure why they're doing that. Right. Hopefully noise blanker was off. Yep. Then on AM, put the signal generator to AM. We're not on AM, are we? We're on USB. I've knocked it off frequency. Back on frequency. And what do they want you to do? Adjust RT3. Oh, squelch control clockwise. They want 100 microvolts effectively, just a little bit less at 47 minus 47 dBm, and adjust RT3 clockwise so the signal is audible. So back to the picture, and RT3, there's RT1, RT3 is that one. Right, so that's set. Then they want you to switch to auto squelch. They're doing this in AM, like AM's priority. Like, there you go. You can see why I don't want any involving really with this, mate. So we want still AM and auto squelch on, which is there, and they want you to adjust RT1 clockwise, and it's 111 dBm. I'm going to need a chart for that, but it's a pretty small signal. You know what? I'm not going to adjust this because it was absolutely spot on when we ran through it before. So I don't want to adjust it. RT1, if it was fiddled with, RT1, that's 3. There's RT1, which is the auto squelch. Because it's already spot on, I'm not going to touch that. It's like the deviation was all spot on as well. And then in USB, USB, we don't have a USB signal generator. A few people have. I had a friend who's got one, but he threw it in a skip. Connect HF generator to 27206. So we'll adjust the frequency on the signal generator. So we're on AM, USB to minus 47 dBm, so it's back to 100 microvolts, nearly. Adjust RT2 clockwise so the signal is audible. And they want the squelch clockwise. So RT2 must be SSB squelch then. RT2 clockwise so the signal's audible. There we go. Must be squelch for SSB. I think that's it. Good. Glad about that. Now we can't do an on-the-air test with this because we're doing the on-the-air test with the Uniden 200, which we couldn't do when we should have done it because we had a puncture on the Nissan Leaf. So we'll stack. So here we go. Wallow. Let's look on AM. So there's 5, that's 4, so that's still spot on. Good, so we're done. So we'll put it back together. So none of this changes because the squelch will have changed. We'll run through that. I'll kind of temporarily put the lid on. I won't screw it on in case something does need a little adjustment. So I now need to put it back onto UK, which I've done with SSB. So reset that. So just for giggles, we'll check he's doing exactly 4 watts, 79123. So 27,79123. That was done. Deviation was done, and it was 2.2 to 2.5, and it was still 2.2 at 2.5. AM, we end up with 90% plus. These meters are totally fake, so when I key up, it's still reading 9 bars. I could take the output transistors out and it'll still read 9 bars. The S meter, I don't expect is any different. Shall I bother checking it? We're on 27205. We'll do it on CPT and see whether it's giving us a similar figure to what it did on UK. There's nothing I can check on receive because there's no receive adjustments. So we'll just make sure we're on. There we go. 27205, we're on AM. It's better. So it still reads 0.62. You know. It's new set, tick that off. There's no alteration here. We've got, let's do the power. So we'll do channel 1 like we did before, channel 1 CPT, and we actually got 4.1. Channel 40, got 3.9. Oh, we didn't do channel 40, did we? We did the UK. UK 40, 3.9, UK 1. Switch the set off instead of. Funny enough, it's 3.8. So there we go. And we're now drawing. Let's go to channel 20 because we've previously checked it on channel 20. And we've got 2.4. So it's doing 25% more power, isn't it, basically? Nice if that was more consistent, but it isn't. Right, squelch. So I'm going to set threshold, see when the squelch comes in. Make sure I'm on channel 20 CPT because that's what we've got it on. And it's coming in at. I'm actually between scales. Let's try the other scale. It's 0.32. So they're just the same. Squelch tight. Remember, we all set this up as the manual suggested. And you know what? It's 100 microvolts where I'd want it. Auto squelch. Purposely didn't touch because it was perfect as it was. .7, that's what it was before. There we go. Don't know what I pressed there, but it's gone on to another band. Right, I'll put the odd screw in for now. There'll be on the air test for this tomorrow. The only set we're doing tomorrow is not a CB, it's going to be a hobby deviation meter. There were some of these available back in the day. I think it's a type we've covered before. And I'll have to look at my notes, and it's the final item for the trucking and farming business in this out of that current batch. There's more screws to go in, but I'll do that off camera. You don't want to watch me putting all these screws in. Right, we'll put the aerial on. So unlike the Grant 2 Mark II, which we've shown before, this doesn't go smoothly between UK and all that. All it's going to do is FM. So that's why we're keeping it. Oh, I can't. I just have to go and turn the light off. We've got a fluorescent light in one of the rooms, and it's got a really expensive Swiss electronic ballast, and it kicks out interference like nothing at all. That's what that is. I'll just go and turn that off. Right, we'll start again. Oh, it's still quite a racket on. One and a Roger. So if we go to band change, all it's going to do is give us CPT. To access AM and SSB, which we are legally entitled to on this, I think. I will just check on the back. So we're on channel 9. As long as it's CE approved, it is CE approved. It's supposed to be made after 2014, I think these were 2013. So there we go, the Grant 2 ASQ as it's known, ASC, Grant 2 ASC, not the Grant 2 Mark II. So there we are, that's an alignment as per manual. So thank you for watching, and we'll be doing an on-the-air test for this tomorrow.